Good evening, we continue permutations and combinations. Yesterday, we have worked some problems. Today, we'll continue that. This is a problem from CET paper. A group problem from CET examination paper consists of four girls and seven boys. Four girls and seven boys. In how many ways? In how many ways? How many ways can a team of 5 members? Can a team of 5 members be selected? Be selected if the group has at least one boy and one girl. At least one boy and one girl. The only thing is you have got to first analyze the problem clearly. There are 4 girls and 7 boys. You have to select a committee of 5 people. What are the possible cases you should decide? You can one boy you can select and 4 girls you can select. That is one team. The second case is you can select 2 boys and 3 girls. The third case is you can select 3 boys and 2 girls. The last case you can select is 4 boys and 1 girl. The problem looks a little lengthy, but it is not that difficult. Now, 1 boy can be selected from 7 boys in 7C1, and 4 girls can be selected from 4 girls in 4C2. This is 7 into 1, that is equal to 7. 2 boys can be selected from 7C2. You can correct 4C3. See, 7C2 into 4C3 is 4C1. 7C2 is 7 into 6 by 1 into 2. 4C1 is 4. So this is 84. Now 3 boys from 7C3 and 2 girls from 4. This is 7 into 6 into 5 by 1 into 2 into 3. This 6 you can cancel. 4C2 is 4C3 by 4 into 3 by 1 into 2. This 2 you can cancel. So this is 210. How to multiply it first? You multiply 5 into 10, then 7 into 3, 21. The last case, you can select 4 boys in 7C 4 ways. That is equal to and 1 girl in 4C 1 ways. 7C 4 is 7C 3. 7C 4 is 7C 3, that you remember. NCR is equal to NCN minus R. So 7C4 is equal to 7C3. 7C3, 7 into 6 into 5 by 1 into 2 into 3. And this is 4C1 is 4. So this is 140. You add up all that. When you add up all that, what is how much you get? So you get 441. They would have given different answer, you can select this. But the problem students have is, sir, ಯಾವಾಗ add ಮಾಡಬೇಕು? ಯಾವಾಗ multiply ಮಾಡಿದ್ರೆ confusion ಇದೆ. Because fundamental principle ಏನಿರುತ್ತೆ? If one thing can be done in M ways, second thing is done in M ways, two things can together be done in MN ways. ಇದನ್ನ ಯಾಕೆ multiply ಮಾಡಲ್ಲ ಅಂತ. ಇಲ್ಲಿ once you select 1 boy and 4 girls, the job is over. See, once it is completed, if it is not completed, something like 5 boys and 3 girls if arranged, then we are going to multiply because the arrangement requires arranging the boys first and then girls, depending upon whatever conditions given. Here, each one is independent. Therefore, you have got to add that. Let us work one more similar problem so that you will have a better idea of problems like this. In how many ways? I think I am clear here. They say at least one boy. You cannot select all the 5 boys because there must be one girl. So there is no other possibility. So these possibilities you should discuss. And you should be very good at multiplication. Times 4, 7 is 4. Immediately you should realize 7 7 into 6 by 1 into 2, 42. You have 21. You can multiply by 4, 84 you get. So you have to be very quick in multiplication. Otherwise, it requires more time. So it depends on how good you are in calculation. A similar problem. In how many ways a committee consisting of 3 men and 2 women. 3 men and 2 women be chosen from 7 men and 5 women. You must understand the actual difference between the previous problem and the present problem. There was a condition, at least one boy, one girl. Here it's very specific. So there is only one possibility. The committee should have 3 men and 2 women. How many men are there? 7. So we can select a man in 7C 3 ways. How many women are there? 5. Let us select 2. Yes, a simple multiplication. 7C3, 7 into 6 into 5 by 1 into 2, 2 into 3. And 5C2 is 5 into 4 by 1 into 2. So 6 will cancel. 2 4 this is 35 and then 50. Got it? Here 7 into 5 35, 5 to the 10, 350. So you must understand difference. Here there are no cases because very specific. They want 3 men and 2 women. So you have to select 3 men from 7 men in 7C 3 way. The problem is not over. You have to complete the problem by selecting 2 women also. Therefore, we are using fundamental principle here. Men can be selected in M ways, women can be selected in N ways. Both of them can be selected in M and N ways. Let me work one more problem so that we'll have a clear idea of these sets of problems. There are 10 men and 7 women. There are 10 men and 7 men. A committee of 6. A committee of 6 consisting of at least 3 men and 2 women. At least 3 men and 2 women can be formed. So here you should have different cases. The previous problem was very specific. They wanted a committee having 3 men and 2 women. We are supposed to choose from whatever is available. Now we have got 10 men and 7 women. You must select 6 people with this condition. At least 3 men. So case 1 is 3 men and 3 women, because you want a committee of 6. So 3 men is 10C3 and the 3 women is 7C3. Next, case 2. 4 men and 2 women. 4 men is 10C4 into 7C2. Now, case 3. 5 men. There are 7 men. Sorry, 10 men, and you can select 5 men. But the moment you select 5 men, you can put only 1 woman. But the condition that there are also 2 men. Therefore, these are the only 2 possibilities. I repeat, you can understand the concept. A committee should have 3 men and 2 women. So what we did in the first case is we selected 3 men and 3 women. It was 6. Now I can select 4 men and 2 women. That is also. I cannot select 5 men. The moment I select 5 men, the committee should have only 6 people. Therefore, you have to select only 1 woman. But the condition is there that the committee should have at least 2 women. Therefore, only 2 possibilities. So you can just work it out. What is 10C3? 10 into 9 into 8 by 1 into 2 into 3. And 7C3 is 7 into 6 into 5 by 1 into 2 into 3. And this is 10C4 is 9 into 8 into 7 by 1 into 2 into 3 into 4 into 7C2 is 7 into 6 by 1 into. You have to multiply this and simplify. Of course, what happens here is you can cancel 3 3s and 3 4s. Here it will go. So this is 120 into 35. How much is that? So if you know multiplication of 12, 12 5s are 63 and 12, 6 is left over, 36, 42. So 10, 4,200. You have to be very quick in multiplication. How I multiplied was, I multiplied 12. So always keep 0. Multiplication is here. 35 and 12. So you know the multiplication 12 5 is 60 and 4,200. This you can cancel 4 and 2, and you can cancel 3 3s, and here also you can cancel. So here it is 24. So it's a, you're going to multiply that and see how much you get. So I have worked it out. It is 44,100. When you add up this, you get 86,110. 8,000, sorry, 4,000, 8,600. So you have to be very quick in calculation that you can do it. Now, we will work a similar problem, but instead of committee, will have a different concept. Of course, the concept is same, the wordings are different. In an examination, there are 3 multiple choice questions must be answered. There are 3 questions to be answered. Three questions to be answered. What type of questions? There are multiple choice. Just as we have got multiple choice questions in CET, there are 3 questions of multiple choice. Each question has 4 choices. Each question, the same thing as CET, has 4 choices. 4 choices. Number of ways in which a student can fail. Here not pass. Number of ways a student can fail choosing the correct answer. Choosing the correct answer. This type of question has been asked in examination. So, number of ways how a student can answer. Because there are 4 choices, you can answer first question in 4 ways, second question in 4 ways, third question in 4 ways. Every question has got 4 choices. The first question can be answered in 4 ways, the second question can be answered in 4 ways, third question. Totally, there are 64 ways of answering. But you know that out of this, only one answering is correct. The correct answer first question is 1 ways, second question is 1 ways, third question is 1 ways. Therefore, number of choices for failure is 63. I repeat, there are 3 questions. Number of ways he can fail by choosing a correct answer. Given a question, there are 4 choices. So you can put the answer as A or B or C or D. For each question, there are 4 choices. So, first question in 4 ways, second question in 4 ways, third question in 4 ways. It is 64 ways. But you know that one of the answer, only one answer is correct. So you can write a correct answer in first question in 1 way, second, that is total 1 ways. How many ways he can fail? 63. Just to clear it. Supposing in case they are given 5 questions. Then what is the possibility? First question in 5 ways, second question in 5 ways, third question in 5 ways, fourth question in 5 ways, and fifth question in 5 ways. You have to multiply this and you have to subtract all the time 1 only. Supposing they are given 4 questions, 4 into 4 into 4 into 4, 256. You have to subtract that. So this type of question was asked in the examination. If it is not familiar to you, it becomes a difficult question. The object of studying or working out previous year's paper will help you in a long way like this. There is another question. The number of ways a student can choose. A student can choose 4 courses. 4 courses as subjects into it out of 9 courses. And by the courses are subject. Out of 9 courses, where where 2 courses are compulsory. See, these permutation combination problems are very tricky, very simple if it is followed. The only thing is you should understand the concept. How many courses are there? 9 courses. How many courses student has to choose? 4. So it is 94. Normally we write. That will be one of the answers. But there is a condition. What is the condition? Here, 2 courses compulsory. There is no choice. The choice is only for 2 questions. Therefore, answer is 932, not 934. 9 into 8 by 1 into 2. So that is 36. If there is no condition, then you could have written answer as 94. But 2 courses compulsory is no choice. The choice is only for 2 questions. But this is also wrong. Why? When you have chosen 2 courses, the first answer they would have written 94. The second answer they would have written 96. Because normally the 4 choices are given, which are the all possible choices by doing mistake. The answer is not 94. Because 4 courses he has got to choose. There are 9 courses. 2 courses compulsory means only 7 courses are left. This is where the analysis comes. I repeat, there are 9 courses. So 2 courses are compulsory. That means out of 9, 2 is subtracted. You have got 7 courses. From 7 he has to choose only 2, not 4. Because 2 is compulsory. 7 3 2, that is 7 into 6 by 1 into 2. That is answer is 20. So they would have given 4 answers, 94 or 36 and 21 and none of this. There is another problem. These problems will give you a clear idea of permutations and combinations. In the examination, there can be only a small twist in the question, or the number may be different, but the concept required is same. In how many ways 3-digit number can be formed using 1 to 9? How many ways? Yesterday I have discussed this, but I am repeating this. How many ways can 3-digit number be formed using 1 to 9? 1 to 9, there are 9 digits. Whenever they say 3-digit number, you write 3 boxes. And just working this problem to help you to recollect yes, what we did yesterday, and we have done a number of problems. This is similar to filling 3 boxes with 9 digits. There is no condition. Yesterday we worked for a problem, then the number should be more than 6,000, or another case, the number has to be even or odd. There is no condition. So first box you can fill in 9 ways, second box in 8 ways, third box in 7 ways, or you can directly write 9C3, that is 9 into 8 into 7 by 1 into 2 into 3. 3 3 are 9, 2 4 are, and 3 is 84. It's a simple problem. Supposing they say, how many even numbers are there? How many even numbers can be formed? The same problem, I've just taken this problem to give a clear picture of how the problem works out. And then to a certain extent, it will be revision of what we had done yesterday. The same problem. How many even numbers can be formed? See, the even numbers are 2, even digits are 2, 4, 6, 8. So if you want even number, you have to concentrate on the first box rather than the last box. So this you can fill it up. Either with 2, that means you can fill this in 4 ways. You can put any one of this. You are not use all of them. You use only one of them. That means 8 are left over. This is 8C2. 8C2 is 8 into 7 by 1 into 2 into 4. 2 2s are. So this is 14 into 8. 112 this. Supposing, I think, am I clear? When they say that even number should be even, you have to concentrate on the last digit. That can be filled with any one of this 2, 4, 6, 8. So after filling up that, you are left with 8 numbers because one number is already used. And there is possibility of 2 boxes are there, 8 digits are 8C2. Supposing you are asked how many of them are odd. So what is it you can do? Which are the odd digits? 1 is there, 3 is there, 5 is there, 7 is there, 9 is there. So there are 5 odd digits. Therefore, you can fill up this with 5 ways. This is same thing, 8C2 only. That is 8 into 7 by 1 into 2 into 5. So this is 4 times 140. Let me work one more problem which is almost similar to that and to make the concept very, very clear. The problem is the number of arrangement which can be made. The number of arrangements which can be made using all the letters of the word, L-A-U-G-H, laugh. If vowels are adjacent to each other, which are the vowels here? Vowels are A and U. So when you are arranging it, either it can be AU or UA. They should be together. That means that can be arranged in 2 factorial ways. We'll come to that later. Yesterday, while discussing a problem, I gave an example. Some 3 girls wants to be together, or 2 boys wants to be together. I just or yaar ಒಟ್ಟಿಗೆ ಇರಬೇಕು ಅಂತ ಒಂದು ಗೋಣಿ ಚೀಲ ಹಾಕ್ಬಿಡಿ. ಅವಳದ 4 ಜನ ಪ್ಲಸ್ 1 ಗೋಣಿ ಚೀಲ ಅರೇಂಜ್ ಮಾಡ್ಕೊಂಡು ಆಮೇಲೆ ಗೋಣಿ ಚೀಲ ಬಿಚ್ಚಿದ ಕೂಡಲೇ ಅವ್ರಿಗೆ ಪಾಸಿಬಲ್. ಅದೇ ತರ ಇಲ್ಲಿ 2 girls have to be together ಅಂದಾಗ ಇವೆರಡು ಒಟ್ಟಿಗೆ ಇದ್ರೆ 1 2 3 4 ಹೊಡೆಯೋದು. ಫಸ್ಟ್ ಲೆಟರ್ ಇಸ್ L, in EU together G and H. 1 2 3 4. Let us arrange 4. That can be written in 4 factorial ways. Now this can be arranged in 2 factorial. 2 factorial is 2 ways. Yesterday I told you have to remember up to 5 factorial. What is 4 factorial? 24. 24 into 2 is 48. 4 factorial is 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, 6 factorial is 720. So all this you should remember. So this we will move on to the next chapter, binomial theorem. Every year they will not ask a question of binomial theorem. Then there is no condition question need not be asked. There is a choice of the examiner. But normally you get 1 question of 1 mark, and every mark is important. And especially at I told you wherever you can get the marks, we should not lose it. 1 mark is equal to, I discussed this in my very first class on Saturday. 1 mark may be equal to 1000 rank. We don't know. So let me just have a clear idea so that what problem is asked, it should be easy for you to work it out. What are the concepts you need to know? First of all, you should have an idea what's a binomial theorem. N should be positive. The expansion is nc naught x to the power of n e to the power of 0 plus nc1 x to the power of n minus 1 into a plus nc2 x to the power of n minus 2 into a square plus etc. We have a term called ncr x to the power of n minus r into e to the power of r, and the last term ncn x to the power of 0 e to the power of 3. So there are many things you need to know. So note the point. Point number 1. How many terms are there in the expansion? Starting from 0 up to n. So the expansion has n terms. Expansion is n terms. Now, what do you notice? NC naught, NC1, etc., NCN are in order. And you also know that NC naught is NCN, NCA, NC1 is NCN minus 1. What is the meaning of that? The coefficient is first term is same as the last term. So the coefficient terms equidistant from both the ends are equal. Coefficients of the terms equidistant from both ends are equal. I have written NCR. What is the number of this term? See, when NC naught is there, it is first term. When NC1 is there, it is second term. So this term is called TR plus 1, not TR term, TR plus 1. That is NCR x to the power of n minus r e to the power of. The possible question is, they may give a question like this: x plus 3 to the power of 7. Find the sixth term. So you should write the formula. If you want sixth term, put r is equal to 5. 5 plus 1. Substitute and get the solution. Another point you need to remember. Yeah. We'll move on to the CET questions, and then let us list some of the points. The question asked in one of the examination CET was the total number of terms in the expansion of x plus a to the power of n. No, they have given 47. 47 minus x minus a to the power of 47 is. So you should remember, when n is odd, the answer is n plus 1 by 2. That is 47 plus 1 by 2, that is 24. One of the year that asked a question, x minus a to the power of 100 minus plus or minus whatever it is, x plus a and the other one is x minus 100, how many terms are there? For this you should remember, when n is odd, answer is n by 2 plus 1. I can explain this. 100 terms are there. What happens is, all the odd terms get cancelled. There is a minus sign. So when the power is 100, the total number of terms is 101. Number of terms in the expansion of x plus a to the power of n is n plus 1. 101 terms are there. Because there is a minus sign, all odd powers will get cancelled. So you are left with how many odd powers are there? It is from 0 to 99. There are, you can calculate, there are 1 to 99. There are 50 terms. So out of this 101, 50 will cancel. You get 51. That you can always remember n by 2 plus 1. The middle term concept you can use. How to find the middle term? N plus 1 by 2. When n is even, and when is odd. And when is even, n by 2 plus 1. So I think you know this formula. How to find the middle term of an expression? If n is even, it is n by 2 plus 1. I can give a simple example. 1, 2, 3, 4, 5, 6. Okay. Now, what is the middle term? N by 2 plus 1. What is n? 6 by 2 plus 1. So these two terms are called middle terms. So I repeat this. When n is odd, n plus 1 by 2. Otherwise, you got to calculate and work it out. Here 100 is given, so this will not work out. I'm sorry. N by 2 plus 1 will not work out always. So you got to calculate. And 100 is there, 101 terms are there, 50 terms will cancel based on that. But for odd number, the formula will hold good. For even number, there is no definite formula. So we'll not go for that. Normally they ask a question in CET, odd numbers only. One more here, they ask a question. If n is a positive integer, if n is a positive integer, I think it was 2023 this question has come. The number of terms in x plus y plus z to the power of to the power of 10. Number of terms in the expansion of x plus y to the power of 10. That was the question. So for this, please remember the formula. The number of terms in the expansion of x plus y plus z to the power of n is n plus 1 into n plus 2 divided by 2. So remember that. So how many terms are here? 10 terms. Therefore, it is 11 into 12 divided by 2. The answer is 66. Actually, we have binomial theorem expansion for a plus b to the power of n. This is a different problem. But we can use binomial theorem by combining x and y as one term. And normally it's asked in CET 1 year, they can repeat the same question. So remember, it is n into n plus 1 by 2. What are the other questions they can ask? The other question they can ask is independent term. Independent term. Or coefficient of any term. The first thing is, how many terms are there? They can ask, they can always say n plus 1, that's an easy question. The second thing is, x plus a to the power of n plus minus x plus a to the power of n, how many terms are left over? So normally they give an odd number only. For even number, there is no definite formula. So it is n plus 1 by 2. Or the other one is, how many terms are there in x plus y plus z to the power of n? It is n plus 1 into n plus 1. n plus 1 into n plus 2 divided by 2. This is a third possibility. Independent term they will ask. Some expansions are given x plus 7 to the power of 5 or 6. They want an independent term, something like this. For all that, I'm just explaining orally, will not work out any particular problem. Because so far they have not asked. The possibility is that you write the formula TR plus 1 is equal to NCR x to the power of n minus r a to the power of r. Now, if you want an independent term, whatever number you have got, supposing you have got n minus 5 equal to 0. So n is equal to 5 fifth term. If you want independent term means that term should be free from x. The x power should be 0. So whatever number you have got on the power of x equal to 0, you get. That is one thing. They want a particular term, coefficient of, say, they want coefficient of x cube. So in that case, equal to n minus r is equal to whatever, supposing it is n minus 5 equal to 3, you get n is equal to 8. Something like this. I repeat, for both the things you are using this formula. NCR is equal to TR plus for this NCR x to the power of n minus r a to the power of r. X is the first term and e is the second term. You are writing, substituting this. If you want independent term, see that the power of x should be equal to 0. Whatever is there equal to 0. If you want a coefficient of x cube equal to 3, or you want coefficient of x, you can equal to 1 and solve the problem. These are the different types of problems that can be asked in the examination. So with that, we have completed the binomial theorem and permutation combinations. So what next class I will be taking up 2D geometry, not 3D, 2D geometry. That is nothing but what you have studied in first PUC, analytical geometry. What are the chapters you have studied there? First thing is straight lines. The next one is conic section. What are the conics you have studied? Circle, parabola, ellipse, and hyperbola. I may not be able to give you the total idea about this chapter because it's very lengthy. What I will do is I will start the questions straight away, see the questions straight away, and try to help you in case if there are any difficulties. Especially the problems on connections are very simple. It can be solved provided you have the equation of parabola and you know the components of parabola. What are the components of parabola? Focus, directrix, axis, then length of lattice system. In case of hyperbola or ellipse, you have got more components. You have got center also. You have got directrix is there. You have got foci there. So I would rather suggest you to try to at least list the formulas and of conic section. And in case of circles, you have got a center and radius. The problems on circles are not that difficult. Problems in conic sections are not very difficult, but you need to know the formulas. Wherever it is required, I'll just brief you. So tomorrow we'll begin this chapter. And before I wind up, again I'm reminding you, if you have anything to ask, if any queries, or if you want me to revise anything or highlight on these areas where we have covered already, because we have got another nearly 10 days where we can do some more than that. We have got class till 12th. We have another 15 days we have. So I thought I'll give more importance on first year, because second year you would have studied number of times, and because you're in touch with that, you have taken the examination. The first year concepts you would have forgotten, that's why given more importance. So once first year is over, I'll take up second year. We'll go in the order, whatever order we decide on that. Some of the students have suggested this, sir, go give importance first year. I've started this. Maybe another 2 classes or 3 classes I'll be winding up first year, then begin second year. Thank you very much. We shall meet tomorrow at 9 o'clock. I'll be starting 2D geometry. Okay. 3D geometry, you won't get much questions. I may not discuss about 2D geometry because you will not get more questions on that. So 3D geometry we are not discussing. Okay, we'll just complete. Thank you very much. Shall meet tomorrow.